Thank you very much for coming and spending your afternoon with me. It's my pleasure to be here. I think of any spot I can talk about breaking things on purpose, SREcon has to be the right place and the right audience, particularly because I'm lazy and I don't like to get paged, and so it's about solving that pain. So I'm guessing a lot of people in this room have felt that pain. So let me start by giving a little background. Let me tell you a little bit about who I am. I started doing failure testing at Amazon about 8 years ago. I was a member of the retail website availability team. So it was our job to make sure dub stayed up, didn't go down, Black Friday especially. One of the things that we did to help with that goal, one of the proactive things that we did, was failure testing. We went out and we purposely broke critical services or pieces of our infrastructure to understand how they failed, so that we'd be prepared when it happened in production. One of my claim to fame, the service that I built within Amazon, DynamoDB used that to test their resilience to network partitions and to ensure that their data consistency worked as expected. So I'm proud of that. After Amazon, I moved on and I went to Netflix. I figured if there's a place you can learn more about breaking things, it's got to be Netflix. And I wasn't disappointed, lots of breaking things going on, but there was an opportunity for me to come in and to contribute. And for that, I'm grateful. So within Netflix, you might be familiar with Chaos Monkey, Chaos Kong, Chaos Gorilla, all very helpful, useful monkeys or simians. But there was another monkey that wasn't getting let out of the box very often, Latency Monkey. Whenever Latency Monkey was being run, it was causing more pain than expected. It was biting the developers. And so we needed a solution that allowed people to slowly build their confidence in distributed systems and in their failure testing. So I had the opportunity to build a service called FIT, Failure Injection Service, not a real imaginative name, but it allowed us to do things like impact an individual request and see how that request behaved as it propagated through our microservice architecture. And in particular, once we understood how that request behaved, so we verified that it worked correctly for a test user or a test device, then we could do things like run it for 0.01% of production traffic, run it for 1% of production traffic. And we could dial it up, we could ramp that up as our confidence increased until we ran those failure tests at 100%. And so I'm a firm believer in running in production. I'll cover that later. And running it, when possible, at 100% failure in production. So one of Netflix's core values, and that I enjoy and that I like, is context, not control. So I'm not here to tell you what you need to do, but I'd like to set some context and convince you that failure testing is a proactive tool in our toolbox and something that we should be leveraging. So it's funny. What's the opposite of fragile? I like to ask this question with a wine glass on it. If this wine glass experiences change, if it falls to the ground, if S3 goes down, that wine glass is going to shatter. It's not going to handle it well. What we want is we want the opposite of that. Raise your hand if you think the opposite of fragile is robust or resilient. So that's where I started. I would have raised my hand a while back. There's a great book called Antifragile by Nicholas Nassim Taleb. Tammy just talked about Black Swan in her lightning talk, so I feel in good company in my reading there. But he talks about this concept of anti-fragile. We want things that don't just return to normal or go back to steady state. We want things that improve over time, things that are going to get better. And so the analogy that I most often draw here is that of the vaccine. It seems a little counterintuitive to say, hey, we want to inject something harmful into your body in order to build an immunity, in order to make you stronger. But yet, when you draw this back to the medical world, well, I guess, past few years maybe this was contentious, but in general, people understand this concept and it makes sense. So when I think of this as the exact same way when it comes to our distributed systems. We want to inject little bits of harm into our systems in order to build these immunities, so that the types of things that occur, whether it's Amazon, whether it's a cloud provider, whether it's a disk failure, the common colds of the cloud world, that we can handle them in step and without issue. And to go a little deeper on anti-fragility and on what this means, something that's anti-fragile is something that has a bounded downside and an unbounded or a larger upside. So in this case, when we're talking about the vaccine, the downside is you may get sick. You introduce this foreign agent into your body. But the upside is, you're going to have a small version of the illness, but you're going to be immune to it moving forward. And there's some even other nice effects. If everybody's immune to it, it turns out it helps stomp out the disease even more. I think this applies very well to failure testing as well. Our bounded downside is the cause, the impact that we can cause when running this failure test. So if we go out and we run this failure test and we break everything, well, that's kind of on us, but it's a bounded downside. We know what happens. And in fact, because we're planning the exercise and we've thought it through, hopefully we don't have to do root cause analysis. I'm not going to say that there isn't emergent behavior or bad things can't occur, but typically we know what the root cause is and we know how to revert it. But when it comes to the upside for failure testing, there's a lot of things that we gain. Not only do we gain preventing that outage in the future, we gain the engagement time to get on the call to figure that issue out. We save the time that it takes to understand our dashboards, the added benefit of having the opportunity to train and practice before an incident occurs. And if everybody does it and our systems are all in a healthy state, we're all more in tune and better aligned with how our services fail and how to operate them. This came across the morning paper. I'm a fan of the morning paper. I read it where possible, but the headline says it all here. Simple testing can prevent most critical failures. I've found in my experience this to be true. I think in part because we're a little bit young in this space and there's a lot of low-hanging fruit. I think that a lot of companies can get a lot of value in failure testing by doing even the most rudimentary things. Chaos Monkey's, I think, a great example. Like you're just going to reboot a host. You're just going to ensure that your services in general handle statelessness well. But you find a lot of issues and problems that you can fix there. Same thing with testing if you can lose a dependency or any other of these simple low-hanging fruits. So I want to talk about what I think effective failure testing means, how I go about doing it. I'm going to kind of frame this in the context of my experience. When I worked at Amazon, when I worked at Netflix, a lot of times we would meet with service teams in order to help them harden their services, in order to help them prepare. And often this process looked very similar. It started with one question. I had a great conversation in the hallway earlier. I think you get so much value, similar to the low-hanging fruit, I think you get so much value by just asking what could go wrong. Sit down with the team, you whiteboard out their service, you start drawing things on the diagram, on the whiteboard, and pretty soon you see, oh, there's a lot of things that could go wrong. This is an example service graph from Netflix. It's a simplified one. The API service, request comes into API. Each of these is gated by Hystrix. Hystrix is a circuit breaker pattern, if you're not familiar with that. It makes a network call out to a remote service. So just by sitting down with the team and talking about these inflection points, these key places where failure could occur, we can learn some things about our service. If you ask this question and an engineer immediately gets nervous, that's probably a good sign. You want to unearth those things and find them. The analogy I draw here is to that of the threat model. I think it's fairly sane and straightforward to think of, when you want to harden your service from a security perspective, you think about all the potential vectors of attack, all the things that could go wrong. Similarly, when we're doing failure testing, we want to ask those same questions. What are the things that can go wrong? Where are they going to fail? In my experience, most often we see failures at network boundaries and on service boundaries, but obviously that's not always the case. Another question is, how likely is this to occur? I think this is a little bit of a double-edged question. I think on one hand, if you look back over incidents that have occurred in the past year with your service, if you see any patterns, if you see things that are failing in similar ways consistently, clearly that's something you should go and address, something that you should try to mitigate. The flip side to that argument is the black swan argument. the unknown unknowns. If you're always preparing for things that have happened in the past or things that you think could be a problem, you may not prepare for that unknown event. And so I think it's good it's like prioritizing a backlog. I think it's good to think through your failure tests and the kind of failures you want to cause and ask, how likely is this? But you still want to get to the bottom of the list at some point. Another question, what's the cost of being wrong? This is probably one of the more fun questions. Some of the ways I phrase this, if you're Netflix, circa 2013, and you're running in a single availability, in a single region, and that region goes down for a day, what's that impact going to be to your business? Are you going to lose customers? Are you going to damage trust? What about your brand? What about the cost for engineers that need to be on call fixing it? What about all the transitive things that end up contributing to the cost of this outage? And this can factor in, similar to the last question, if you know that some costs are just too prohibitive, that you can't handle them, if you have a business-ending failure mode, it's probably worth thinking through that, maybe running that exercise, even if you think it's very unlikely to occur. So some metrics. Everybody loves metrics. I was Googling on the S3 outage to try to get a gauge for how expensive that was. I think you can take what you will for that. One article pegged it at being a $150 million typo. I'm guessing they're aggregating costs to everybody and not just Amazon there. PagerDuty recently produced an article that talked about the cost of downtime. And in one of its sources, it talked about the average cost of data center downtime is $5,000 to $10,000 a minute. So if you have a 20-minute outage, if it takes you 10 or 15 minutes to get everyone involved and fix it, you're already looking at a $100,000 outage, potentially. If it's down for 4 hours, you're over $1 million. Having experience on e-commerce, if you're Amazon and you're down on Black Friday, that number adds up super quick, super fast. Likewise, it was estimated that when Facebook went down, it was about a year and some change ago, that they lost $1.7 million in advertising revenue for the period that they were down. So one of the things that I want to emphasize, one of the things that I think is important in the cost of downtime is we as an industry need to be able to go to our management and to our executives, and we need to be able to quantify the value that we're providing. A lot of people say, hey, I care about 3 nines, I care about 4 nines, but what does that translate into for the business? If the difference between 3 nines and 4 nines is $10 million, should you fund an SRE team to go fix that problem? Should you invest more heavily in that space? I think once you can reduce it to dollars and cents, it makes it a lot easier to have that conversation. All right, so we know why it's important. Let's talk about some specifics of how we want to actually accomplish this. What do we need to do to validate our assumptions? The way I like to think of failure testing is like an experiment. We have something that we want to learn. We have a hypothesis that we want to validate. So I'm going to fall back on some Netflix examples. At Netflix, there's ratings that movies have. What happens if the rating service fails? Well, having been through one of these exercises, we assume that members are just going to get default ratings, something cached or something computed or not computed on the real fly, but something cached. So great. Now we know what it is we want to test. What happens next? Well, we need to measure it. How do we know that our failure is behaving correctly? And this is a fun one because I think we do a lot of anomaly detection. We do a lot of thought about how we detect failure. But when failure is behaving as is expected, how does it show up in your graphs? What does it look like? In the case of a lot of the Netflix testing we did, Hystrix was our key that we used there. Whenever Hystrix encountered a failure, we'd have a metric emitted that showed us that a fallback was served. And so from that, we knew that we had gracefully degraded. So while running a failure test, if we saw fallbacks spiking or raising at a large rate, then we expect that. That's the metric that we want to see. Success criteria. Success criteria and abort criteria are kind of one and the same. They go hand in hand. But we need to make sure that while we're running the test, our business is still happy and able to do what it is our business does. So in the case of Netflix, can people continue to stream? If they can, then we know we're in a good spot. If for some reason our failure test has prevented customers from doing what it is they want to do, then we're in trouble. Our failure test isn't behaving how we want it to. And so we want that abort condition. There's a reason all the tools that I built have a big red button that's called halt all, and it's because you never want to be in a Sev 1 or an incident review where you're discussing why a failure test went awry and resulted in real customer impact. You want these failure tests to be such that you can halt them quickly and revert that impact. So I want to give an example here. This is from Netflix. This is the CDN selection team. And one of the great things about Netflix and about building failure as a service is I never directly interacted with this team. I didn't have to go convince them that it was the right thing to do. The tool was made available to them. They had the service. They went out and they ran this test. And so what we have in this graph is the black line is the number of people able to stream. And so we can see that throughout this test, people are able to stream, and it's working as expected. Green is obviously success. Things are working as expected. Right around 11:30, they start running the failure test. We see an increase in fallbacks. It goes almost until there's no successful requests. It might be a monitoring snafu. But we ran it to 100%. We validated that customers weren't impacted, and then we were able to revert the impact and move on. So if you can run a failure test and come up with a graph like this, in my opinion, you're winning. Another important part of running effective failure tests is communicating. Now, it's funny because there's a part of me that thinks when I was a younger engineer and I wouldn't want to necessarily communicate, that I'm going to go break everything or that I'm breaking some service. I might be a little worried things might go off the rails or something didn't work as expected. But obviously, as we mature, we learn that it's better to over-communicate so that lots of people understand what's going on as opposed to under-communicating. I think in this case, there's a clear set of people that are going to be interested. If you're running a failure test and you expect to impact your upstream or your downstream dependencies, you should let them know in advance. If you have a core SRE team or a centralized team that cares about such things or a chat room that people follow along in, you want to let them know that it's scheduled and that you're kicking it off. I've had a number of failure tests where someone has hopped in a room and been, hey, I saw this metric, this looks wrong. And it was a great experience because we could go, yep, that's expected. We're causing that failure. Things are working as they should. I think it's important to share your pass-fail criteria. You want people to know what success looks like when you're causing a failure, and you want people to know at what point we stop everything and roll it back. And then I think there needs to be some sort of a command center. Somebody said they didn't like incident commander, so maybe commander's not the right word, but you want a central place that people can check in and understand what's going on. Whether it's a chat room, whether it's a conference bridge, whether it's in person, one source of truth that anyone that's interested in this failure test or thinks that something might be going wrong can step in and get up to date. The next thing that I think is important, and I alluded to this a little bit at the beginning, is the scoping of the failure. So it's probably not a good idea for your first failure test to go out into production and just take out a data center or take out an availability zone. That's not prudent failure testing. We want to start with the smallest possible impact that will teach us something, whether that's on our laptop or our desktop, whether that's a single host in test. We want to understand how it's going to behave. And then as we understand how it fails, we want to grow our failure scope as our understanding grows. We want to go from running on a single host in test to running on an entire service in test. Maybe we want to run it across the entirety of our staging or integration environment. And then lastly, we want to move to prod. Same principle applies. What's the smallest impact we can run in prod? A single host, a single instance, a single request. And for each of these, we can validate that it's behaving as expected, and then we can graduate up to the next level or stop. It's one of those diagrams, found a bug, stop. go fix it. And then once we're running in prod, I think we want to dial it up. I think this is important because we learn different things at different levels, different granularities of failure testing. When we're running on a single box or a single request, we're often seeing functional behavior. Does the UI handle a fallback correctly? Does the service return, degrade correctly and return a 200 or throw a 500? These are things that tend to be a little bit easier to catch and that can be done in closer to isolation. As we scale up to running at prod level, there's a different set of things we're learning. We're learning about our resource constraints. We're learning about queuing within our system. We're learning about cascading failure. And while it's a bit more dangerous, we have an opportunity to see how our system really behaves under duress. One of the things that I found, particularly with hystrix and tuning circuit breakers, is that you can't, it's easy to tune for the happy case, which is going on most of the time, and ensure that we think we have reasonable timeouts and thresholds and thread pools. But really, when everything goes to hell, that's the point that we need to understand. Are we protecting ourselves aggressively enough? Are we properly throttling requests? Do we shed load as we anticipate? And so I think it's important to test those and to verify those things so that later, when that incident really does occur, it's a non-event and it happens smoothly. And then I think it's very important to test in production. Similar to Antifragile and Drift into Failure by Sidney Dekker, another paper that I would put in the SRE Bible or Holy Book would be On Designing and Deploying Internet Scale Services by James Hamilton. He's a distinguished VP at Amazon now over the cloud, but he came from Microsoft Research. But in that, he makes a quote that I think says it all. Those unwilling to test in production aren't yet confident that their service will continue operating through failures. And without production testing, recovery won't work when called upon. I think this is duly important for the recovery piece. Oftentimes we've thought through these different failure modes, we think we know how things are going to happen, we have a plan of attack. But if we haven't executed that plan of attack, if we haven't had an opportunity to practice it yet, we may find that there were bugs in the way we implemented it. We may find that something doesn't behave the way we expect. And so if we really want these things to save us, to be ready when they're called upon, we have to do it, we have to prepare. And this kind of led me to this thought, this is kind of not fully matured, but this concept of productionalization. I think this is something that we often go through with our services. We think through the potential failure modes. We set up monitoring. We set up alerting. We set up engagement so that we'll get paged if things go wrong. And I think generally that's where a lot of people go, and that's kind of the end of the road for some people. I think that for that to be really effective, you need to be able to test that your engagement works. Another hallway conversation I had today, was reminiscent of an outage I've seen several times. There was a team. They set up an alert, and they expected to get paged. And the alert was set up wrong, and their paging didn't happen or wasn't set up correctly. And so an incident that might be relatively straightforward or self-contained is exasperated by the time it takes to just get the right people involved and figure out what's going on. So I'm a bit of a geek. This came across my Twitter feed, I guess a little while back now. Turns out Picard, I think, has some pretty good management tips, or whoever writes it. But he talks about, we got to run crisis drills when everything's well. 2 a.m., when production's on fire, when everyone's on a call and worried and trying diligently to fix things. It's just not the best time to ask a lot of, entry-level questions. It's not a good point to say, hey, I'm not really sure, where my dashboard is, or I'm not really sure how to understand how this part of my service behaves. And I think we've all been in that boat where, we join a team, we own a service, we take over a service, it works pretty well. Maybe we haven't done that deep dive into it. Maybe we haven't had to put it out yet when it's on fire. And so being able to run these failure tests, during the day, 10 a.m. on a Tuesday, after the caffeine's in, after you've told everyone what's going to happen, seems to go a lot better, a lot smoother. So I want to provide some case studies and some examples of effective failure testing that I've seen and some ways that I think build upon these concepts. Spinnaker at Netflix is an open source cloud independent deployment tool. And when Spinnaker first came out, like any software project, it wasn't quite yet mature. When they first were ready and they were ironing out the bugs, we were going into Q4, and I said, hey, I'm a little worried about Spinnaker. Not because they don't have good engineers or they didn't follow good engineering practices, just because everything fails and everything has problems. And so we met with that team, and it was a great example of this entire process. We whiteboarded out their service, their points of failure, places where they had circuit breakers, places where they needed circuit breakers. We talked about places that their workflow could fail and gracefully fall back, things that, if it didn't absolutely happen or a sub request didn't come through, it would be okay, versus that primary workflow where everything needed to work every time. And one thing that's special about Spinnaker is, within Netflix, a lot of engineers use this tool to build and deploy their services. If, for example, there was a large outage and you couldn't use Spinnaker to deploy your service, a lot of engineers might not know how to do it. Certainly, it can be done by hand, but people get familiar with their tools and their processes. Not to mention all the nice things that are built into a build and deploy system like canarying and red-black and other things that help you deploy safely. So making sure that Spinnaker was really hardened was important to the company. After we talked about what could go wrong, there was this natural discussion about, well, what should we monitor? What does our dashboard look like? And they thought through. And again, not to pick on the Spinnaker team, I think many teams do this. You have a service, you've essentially written it, you're done, but have you thought through all of the things you want to monitor, all of the things you want to alert on? I mean, again, this room, I'm sure you guys do, you guys and girls do, but not everybody does that. The next example I want to give is Chaos Kong. And you're going to notice a theme here. Chaos Kong is owned by the Netflix traffic and chaos team, and they do an excellent job with owning and managing this process. This is something that I didn't really have anything to do with. I just think it's a great example of failure testing in action. So anytime there's an AWS-related outage where Netflix feels it's isolated to an individual region, they evacuate that region. I think Casey might talk a little bit about that. There's some other Netflix talks that talk more specifically about Chaos Kong. But what's important is that this test is run on a regular basis. Every couple of weeks, whether something's wrong or not, Netflix evacuates one of their regions and serves traffic out of another region. And every couple of times that this exercise is run, there's new things that are learned. There's a new service with a scaling boundary. There's somebody that's introduced something that doesn't handle dropping between regions cleanly. There are problems that are found, and those problems can be fixed before they're needed. And so I have written down here 3 different outages that I know that Chaos Kong played a big role in helping Netflix essentially mitigate without customer impact. One in particular was Q4 2015, and I was on call. It was a Sunday morning. I got paged at 5:30 because AWS wasn't giving us new EC2 instances. As Sunday morning ramps up and everybody wants to watch TV on their day off, we knew that was going to end poorly. The great thing of this process and having tested it is that via chat, we were able to start the process of region evacuation, move everything to another region, and be prepared to handle traffic as the ramp came up. And so because of that, it was essentially, it was reminiscent of a couple weeks ago. Everyone was like, oh my gosh, AWS had this incident, everything's broke. Hey, Netflix made it out okay. Well, it's because of this, and it's because of these kind of proactive failure testing that Netflix is able to handle those things in the way that they expect. I want to give an example on automating failure testing. So a lot of these are ad hoc, things that you want to plan, things that you want to execute. I think the next step, once you've done ad hoc failure testing, is to move to automated failure testing. And a great example of this, so while I was at Amazon, we had this question that popped up. What is Tier 1? What is our set of critical services? And the answer was, some PMs had a list of what we all knew the like top 5, 10 services, but there was a list of what we thought was critical. And if you were on that list, you automatically got paged into every large-scale incident. Now, if you weren't on that list and you caused an outage, you just found yourself on that list. But as far as I know, there's no way to get back off the list. Maybe some have. So we had this same problem at Netflix. We wanted to solve this question. And so what we did is we approached it from a different angle. We whitelisted what we thought the set of critical services were. And then we took a set of devices and we automated them in our lab. And so for those devices, we would spin up, log in, browse, pick a movie, and stream, all under the failure test that ensured that it could only talk to the critical services. And what happened is if someone introduced a new critical dependency, that test would fail, and we would have an opportunity to make a choice. We could ask ourselves right then, should this be a critical failure? Should this should this stop people from streaming? And most of the time the answer was no. Let's find some way to gracefully degrade. Let's remove that critical dependency. But every now and then, a legitimate new dependency was added. The important thing is that we knew what those critical services were, and if we wanted to, we could treat them differently. If those services needed to be a bit more hardened because we didn't expect them to handle failure well, we could invest that time. Versus the tier 2 or the other services where we knew in general that if it failed, it wasn't going to stop our customers from doing what was important, and we could live with that. Or we could live with slightly lower SLAs. To build upon that a step further, I had the opportunity to have Peter Alvaro come and spend a summer with me at Netflix. And so what we built was, okay, so cool, we can automate some failure tests. How can we get out of the business of deciding what's interesting to fail? Is there some kind of search algorithm? Can we just throw some machine learning at this? Machine learning plus failure testing equals no more problems? And the short answer is no. I wish. But we had the opportunity to go in and build these concepts. So one important detail here was that at Netflix, we were integrated with our tracing infrastructure. And so from that, we could determine what the interesting failure points were. And from that, then we could apply an intelligent search algorithm. And we could actually cause those failures in production. So what we did is something like 10 requests an hour or some very, very small amount of requests we would decorate with these failures. And some of the times, those failures were gracefully handed or they were non-events, and those requests worked as expected. Sometimes those requests failed. Hopefully the device or the user is going to retry, so it's not something that's going to hard block someone. But from that, we could learn about a failure in our system. That's a bug. That's a hard failure, and we could make a decision. Is this something that won't ever fail? Is this, well, that's a bad way to phrase it. Everything will always fail. But is this something that we needed to mitigate and address, or is it something that we could live with? So top level points that I think are important here. We want to reduce toil. So the proactive failure testing that we did at Netflix, my service, I was on the API. We owned the proxy and the API that fanned out to all of the microservices. By doing this kind of proactive failure testing, we improved the reliability of our service by a 9. We essentially moved from 3 nines to 4 nines. And because we were such a core component of Netflix, we had a similar effect to Netflix's overall availability. But additionally, our on-call burden dropped 20% year over year, both years that I was there. So not only were we, and in fact, that number's still a little inflated, because we were so central and core to the company, we would jump on a lot of calls, or we wanted to be paged, even if there was nothing for us to do. But it came such that many events were no-ops. Things that used to be, hey, you got paged at 2 o'clock in the morning, identity had a problem, or recommendations had a problem, and you need to deal with it. It became things gracefully degraded, they behaved as expected, and we would talk about it the next morning over coffee instead of at 2 in the morning on a conference call. And so I think that in the list of things that we can do, there's a lot of reactive things. I think this is one of the proactive things that we can do to go out and prepare for the kind of troubles that our systems encounter. And so with that, what would a demo about failure testing, or what would a talk about failure testing be without a little demo for failure testing? So Netflix doesn't let me break their stuff anymore, which I'm kind of sad about, but I can understand. But what I want to do, I'm going to use Gremlin, which is my service, to go out and break Gremlin. I tested these in advance. So actually, I'm a firm believer in dog fooding. So we failure test our failure as a service to make sure that it handles failure well. Some would call it dog fooding. Jeff Bezos called it drinking your own champagne. I think that has a better ring to it. Dog fooding might be more accurate, though. So in this case, I want to come in and I want to drop all traffic to S3 West. And I want to see how my service handles that. I'm going to kick this off, and I'll save you a little excitement. So when we break S3, we break one of our install workflows because we store our artifacts in S3, and we're unable to host them. But within our UI, we're able to kick around and continue to function as we expect. So actually it kicks off. Some of them are running. Some of them are still firing off. And so, the S3 service, all right, that's interesting. What's really interesting is one of our other dependencies, Dynamo. What happens if we break Dynamo? Kick this off. We'll give it a second to clean up the other one and do it. But go ahead and show you that it handles it reasonably well, but things still break. Tried to find a good demo that showed things breaking, because who wants to see a demo of it working correctly, right? Like, is that an exciting demo? It's like, hey, I ran this failure test. It looks the same. Are you lying to us? So while that's kicking off, I have actually saved the last 15 minutes or so for questions. So while that's running in the background, I'd be happy to start fielding any questions anyone might have. Oh, there's the hang. That's what I'm looking for. The nice Ajax-y web style. It still loads the pages, but no, that one worked. We got a good server there.
What kind of testing do you recommend for small shops?
I think that, so by small shop, do you depend on any cloud services, Dynamo or S3 or things like that? I think a best place to start is just by failing each of your dependencies. What happens when one of your key dependencies fails? Page is broken now too. I didn't repeat the question, my bad.
So the example that you gave with, I think it was the Spinnaker team, you working with the Spinnaker team in whiteboarding architecture. In what I've seen in my organization is like, when people are in front of a whiteboard and thinking about dependencies, they either forget stuff that exists, or their memory of how a certain thing was configured doesn't match reality and so on. So what do you think about like automating that aspect of it as opposed to doing it through meetings and discussions?
Yeah, I think if you have tracing and you have nice integration with tracing, so for example at Netflix, our tracing system, every time it would touch a place we could inject failure, it would tell us about it. I think that helped us to understand, hey, these hidden dependencies or things that didn't occur. That's the other thing is it may not fail the way you expect. Like you kind of have to go verify it. I've definitely had a discussion with an engineer. Hey, this is in a tight loop, but it does not make a network call. It stays local. Yeah. And I'm like, no, we ran this failure test and something failed here. So I'm not disagreeing with you, but let's dig into it. We dig into the code a little bit, and sure enough, 3 layers down, we find a network call that's going out on the box. And so that's actually, I think, one of the hidden values. Understanding your system and verifying that it behaves correctly and being able to do that in a simple and safe way is a powerful tool to understanding your distributed system. The 4 o'clock question block.
Hey, so you talk about evacuating a service from one region to another. have you heard about evacuating one service provider to another?
You know, I don't know of anyone doing that in production from this like chaos calling. I'm not aware of that. I've definitely heard a lot of talk about, hey, we need to be resilient to a cloud provider going down, and we need to run redundant systems. I think that's, in my experience, a lot of companies that go down that route find it to be quite burdensome, and so I'm sure there's some out there, but I'm not aware.
While we're waiting on your demo, can you show us how to create these attacks?
If anyone wants me to show a little bit more about Gremlin, I'm happy to do that afterwards. Okay. That was the extent of my demo. I just wanted to show some real breaking of something. Okay. Someone had a question right here. They asked me to have you step to the mic.
Yeah. Hi, I'm Tom from Waze. We actually use Spinnaker to deploy multi-cloud and to do exactly that. So we have a blog post about it, and you can go read it. Just search for multi-cloud deployments using Spinnaker in Waze.
Well, thank you. Don't listen to what I say about multi-cloud providers. I don't claim any expertise there. We're not breaking stuff in that. I mean, that's, yeah.
So, name's Tyler Stewart. So, question I have is, I know we talked about the best case to do this is in production, obviously, and completely with you on that. But do you also think there's a good value in doing this as close to the development cycle as you can? Obviously, the further you get out in production, the more costly a mistake is. So what are the thoughts around that?
Yeah, I think it's very important to be able to test as part of your development workflow. One of the things that we were able to provide at Netflix, more than just failure as a service, was a way that as part of integration tests, people could force those failures and see what happened. And so actually it became part of our unit/integration testing that we would do some sane validation right there on the box or in the service. And then really that left the, going across a network boundary or dealing with distributed systems to happen at a higher level in staging or test or the like.
Okay, cool. Thank you.
Thank you. So I threw some stickers down, if anyone likes Gremlin stickers. If you have any questions about Gremlin or about the work that we've done, I'm happy to field them. Come grab me. Otherwise, thank you very much for your time.